This is section 5.2, day 1. Today we're going to talk about definite integrals. And definite integrals are integrals that go from a certain point and to a certain point. So we talked about Riemann sums a little bit last time in class. We didn't actually get into their notation, but this is summation notation. It means I take the sum of all things involved. So before we were talking about our rectangles, so we're taking the sum of the areas of all of our rectangles. So A sub k would be like the area of each individual rectangle. And we're going from k equals 1, so the first rectangle, to n being wherever I decide to stop. Now, how does this relate to the area under the curve? Remember, everything we're going to do this semester is going to deal with the area under the curve. And so the area is equal to the sum of the area of all of the subintervals. Now I can break my subintervals really down into anything I want. We just happened to use rectangles last time because they're more convenient. So we see that Riemann sum comes into play here. This is a much easier way than writing f of 1 times delta plus f of 2 times delta plus f of 3 times delta, and so on and so on and so on. Okay? So it's a much simpler way of writing it. Otherwise, we're still doing the exact same thing. It's not a whole lot different here. Now, where does the definite integral come from? If f is continuous on the closed interval, and the closed interval is partitioned into n subintervals of equal length, b minus a over n, then definite integral of f over ab is given by this limit. And it's the limit as n goes to infinity. And it's to go to infinity so that we can talk about how many rectangles I want. I want as many rectangles as possible to get the best approximation possible. Now, where each ck is chosen arbitrarily in the kth subinterval, that means that c sub k can change, and it changes based on, did I use a left hand, a right hand, a midpoint? What am I using when I am finding it? So this means that the definite integral is equal to the area under the curve, which is what we're trying to find. So, the symbol for integral looks like this, and we will use these symbols from now until the end of the year. It's good to understand them. We recognize a and b as our interval. Remember, as a closed interval from a to b. So that's where the a and b come from. This is the integral sign. So this means integral. Okay. B is my upper limit. A is my lower limit. F of x is what we call the integrand. And then d of x is the variable of integration, just like it was the variable that we're taking the derivative with respect to before. So these are all the parts of our integral. Right? So when we talk about the integral, sometimes we have situations where f of x is above and below the axis. So when I talk about the area under the curve, I'm going to have positive and negative area. So all area above the axis, let's make this a little brighter color. So all of the area above the axis is positive. All of the area below the axis is negative. And once again over here we have positive area again. Okay. So the area under the curve is actually referred to as the net area, because I'm going to take that positive area and I'm going to add it to that negative area, and it's going to give me a little bit of a difference. So when I think about this, it says that the integral from a to b of f of x dx equals the total area above minus the area below. And that makes sense because the area below our curve is negative. So as you work through these problems today, you're going to run into a couple of different kinds of things. The first is an example to express the limit as a definite integral. So we're going to take this sigma notation, as it's called, and we're going to write it as an integral. So I start with my integral symbol, and b goes on top, a goes on the bottom. So remember, a comma b. So integral from negative pi to pi of f of x, which is this part. This is the f of x part. And then this guy is the dx. So of sine cubed x dx. And that's literally my answer. So can you go from sigma notation to integral notation? Now we're going to evaluate the integral. So to do that, we need to think about where we're going to and where we're going from. Well, one of the properties of integrals is that if f of x equals a constant, so just a number, then the integral from a to b of f of x dx equals that constant times b minus a. So in our case, this is our constant. So this equals the square root of 2 times b is the square root of 18 minus the square root of 2, which equals, and all of this can be done on your calculator. If you remember, 18 is the same as the square root of 9 times 2 minus square root of 2, which equals square root of 2 times 3 square roots of 2 minus the square root of 2, which equals the square root of 2 times 2 square roots of 2, because 3 minus 1 is 2. If I multiply by the square root of 2, I get 2 times 2, which equals 4. So the answer to that question is 4. Now, the square root part is probably where you are getting stumped on where did she do that. Just keep in mind, it holds true for all numbers. It's not just because it's the square root of 2. So if I'm integrating from 3 to 7 of 5 dx, that's going to be the same as 5 times 7 minus 3, which is 5 times 4, which equals 20. So 20 would be the area under my curve. Okay. So here it says, use the graph of the integrand and areas to evaluate the integrand. So I'm integrating from negative 1 to 1. Well, here's negative 1, and here's 1. So I'm only looking at this triangle, which is pretty nice. So my base is going to be 2, because from here to here is 1, and from here to here is 1. My height is actually 1. So the area of my triangle equals 1/2 times the base times the height, which is actually equal to 1. So that would be the answer. And I use just my area form. Area equals 1/2 base height. And that took us down here to 1 for an answer. So anytime you can look at the graph, figure out what shapes you know, what shapes you don't, and find the areas of those shapes. Use all of the formulas that you know. You should know for the AP exam: the area of a rectangle, a triangle, a circle, and a trapezoid. Alright, if we move on. Your homework is page 283. You're doing 1 to 22 all. Please, please, please make sure you double check your answers, double check your formulas. All answers are posted to eChalk. The solution manual answers are there. Please go back and double check those.